Hello friends, welcome to my YouTube channel Make Maharashtra. Will gives more educational videos, so do watch, share and subscribe my channel. Clear? Now previous session for belt drive we have covered what will be the speed ratio by considering and neglecting slip. Geometrical relation for open belt drive that we are going to develop. So first of all, just understand what is a belt drive, that is open belt drive which I shown you. So this is the basically belt drive, open belt drive, which is having smaller and bigger pulley. You can see the parameters. So the alpha angle, this will be the here also alpha angle is situated on which the belts are going to release the rotation towards the bigger and smaller pulley. Now center is OS, OB. The angle is theta s. Theta is nothing but the angle of lap, that is contact in between with respect to pulley area. So here angle of contact of angle of lap for driving or smaller pulley, and this theta b is the angle of contact for bigger pulley. Clear? Now of course the distance between two pulleys are called as a center distance, CD we can say, or C. L is the length of belt. So length of means total length, total length of belt. So that is length. How we can calculate? See, I'll tell you. Just wait. Now length, and our title is to calculate or geometrical relation we need to develop for length of belt. Now I'll tell you how to calculate the length. You can see, I can say the arc ABC plus distance CD plus arc DEF plus distance FA is equal to length of belt. That's it. So that equation we need to derive. So this will be the derivation we are going to do for open belt drive. Now one by one I'll explain. Small d, of course, diameter of smaller pulley. Bigger D, that is capital D is bigger pulley. Theta s, smaller angle of contact or angle of lap. Bigger angle of lap is theta b. C is the center distance and L is the length of belt. Clear? Now next part, how to derive this. You can see first from the figure I can say the triangle, you can see carefully, OSGB. OSGB, this will be the triangle we have considered. Correct? So this triangle, according to that triangle, I'll get the alpha value. So I'll write sine of alpha is equal to OBG, this side, OBG, this OBG, divided by OSB, this horizontal. Clear? Now therefore OBG means what? This area. So I can write capital D minus small d divided by 2. So this will be the OBG value, divided by OSB, this we called as a center distance, divided by C. So therefore I can write the equation in simplified format, D minus D, that is bigger pulley diameter minus smaller pulley diameter divided by twice of center distance. Therefore alpha is equal to sine inverse of D minus D divided by 2C. So this will be the equation for the alpha. Correct? Angle of belt. Angle of contact of the driving pulley, this is very important. Angle of contact of the smaller pulley. So smaller pulley case, the relation they have mentioned, theta s for smaller pulley is equal to pi minus 2 alpha. How this comes? You can see here. Smaller pulley, theta s, this will be the theta s, this. Now you can see the area of contact or arc of contact is with respect to this pulley is this much. Clear? How much angle? So that angle is 180. Clear? Now carefully listen, that angle is 180. So 180 means pi, and the alpha is the angle through which the belt is going to release. See, from this belt is going to release with respect to alpha angle, both side. So pi minus alpha, correct? Two side. So can I write pi minus 2 alpha? So that equation will get, and therefore here written theta s is equal to pi minus 2 alpha. Everybody understood? So alpha is this much. sine inverse we have calculated. Sine alpha is equal to, therefore sine inverse of d minus d divided by 2c. So this will be the smallest angle of contact for smaller pulley. Clear? Now for bigger pulley, definitely we'll go bigger pulley. This will be the arc of contact, that is 180 degree pi, and in addition to that alpha is from one side and another side plus 2 alpha. So this will be the for bigger pulley. So I'll write here for bigger pulley is theta b, bigger pulley, pi plus 2 alpha, correct? Pi plus 2 alpha. I'll write here, see, pi plus 2 alpha. 2 alpha is nothing but 2 into sine inverse of same value. So here we'll get the smaller angle of contact for smaller pulley as well as angle of contact for bigger pulley. Now we'll go toward the length, which is our direct outcome. So length is, I told you, arc ABC plus CD plus arc DEF plus FA. See, again I'll explain for your side, for sake of your understanding. See, arc ABC, plus center distance or length CD plus arc DEF plus FA. So this will be the length. So same I have written here. Therefore you will get this L is equal to arc ABC plus CD plus arc DEF plus FA. So one by one, arc ABC is nothing but, you can see, d by 2 into theta s. How? So with respect to angle, arc ABC, you can see arc ABC, clear? Arc ABC, this is d by 2 at center, and angle theta s. So same we have written here for the angle. So d by 2 into theta s for smaller case, clear? Same for CD. CD is nothing but it is a length. As per the angle from the diagram, it will gives you in terms of the center distance, C cos alpha, correct? Are you getting it? This CD is C cos alpha. This angle is, see, C cos of alpha. If I take the alpha value here with respect to this distance, I'll get C cos alpha. Then bigger pulley, of course, instead of smaller pulley, capital small d converted into bigger D, that is d by 2 theta b, bigger pulley C cos alpha, same value will be coming because situated on same structure. And by converting these equations, we'll get d by 2 theta s, smaller pulley, pi minus 2 alpha we have considered, and theta b pi plus 2 alpha, very important, plus this. So after converting this, we'll get the equation L is equal to d by 2 pi minus 2 alpha plus d by 2 pi plus 2 alpha plus 2c cos alpha. Don't remember this equation, it will directly come from the, by putting the values. So don't remember this equation, you can directly make the equation from the diagram, clear? So after rearranging this equation, what happened? Let us see. After rearranging this equation I convert pi into d plus d in smallest format, pi into d plus d plus 2 alpha, because alpha plus alpha, that alpha is 2 alpha into d minus d divided by 2, this value comes, plus this term as it is 2c cos alpha here, clear? So by multiplying and arranging this term, we will get this value. Again simplify this, pi into d plus d plus alpha, 2 get cancelled, so alpha remain here, into d minus d plus 2c cos alpha. So this will be the term. Again for this term I must know the cos alpha value and alpha value. So alpha we have already decided, that is sine of alpha is equal to d minus d divided by 2c, sine alpha already defined. Now sine alpha, so I want cos alpha means 1 minus 2 sine square alpha by 2, correct? See this this equation, mathematical equation, cos alpha is equal to 1 minus 2 sine square alpha by 2. So 1 minus 2 sine square alpha by 2 we have written. So just put the value of alpha here, d minus d divided by 2c. So by putting this value, we will get the cos alpha is equal to 1 minus 2 into d minus d divided by 4c. Clear? So this equation and this equation I will directly put in length equation. So I will get through that 1 minus d minus d 8 of c square. 8 how it comes? So 8 is like this. See, this 1 minus 2 d 2 into d minus d, that d square, d small d square, 4 square 16 and 16 and numerator 2. So divided by 2 divided by 16 it will be 8. That's why it will come 1 minus d minus d bracket square 8c square. Now this equation we got. All this equation we should put in the length equation, and you will get the length equation is L is equal to pi into d plus d divided by 2 plus d minus d into d minus d plus 2c d minus d bracket square 8c square. By rearranging this equation in simplified format, we will get the final equation of the length of the belt is L is equal to 2c plus pi into d plus d divided by 2 plus d minus d bracket square divided by 4c. So this equation we are going to use for the numericals. Now here remember, always here is a minus sign. Always remember, for open case, open belt drive, minus sign. So likewise we can derive the equation. In examination they will ask the question, write a note on or derive an expression for length of belt drive. So in that case you need to add this sequentially with the diagram. Clear friends? I hope you understood the things. So I will revise the part which we have covered in this session. We have seen the diagram, open belt drive, we have understand the parameters, diameter small d, bigger d and all that, and just taken the triangle OSGOB, and through that triangle we have calculated the value of alpha. After alpha we have calculated the angle of contact of the smaller pulley as well as a bigger pulley. Then the length equation I told you according to the structure, just add the values of this. In the length equation we will get L is equal to d plus d divided by 2 pi minus 2 alpha plus capital D divided by 2 into pi plus 2 alpha plus 2c cos alpha. Now by rearranging this equation we put the term of cos alpha and alpha in this, so we will get directly the value of L. So through that L is equal to, for open belt drive, is L is equal to 2c plus pi into capital D plus small d divided by 2 plus in bracket capital D minus small d bracket square divided by 4c. Is that clear? Okay. So this is for the open belt drive geometric relation. So next part will be cross belt drive geometrical relation. We'll see in next lecture. Thank you.